All right, we're on.
Is 3C on this one?
Hold on.
Yes.
Yeah, it is C.
Equal to and not equal to.
Mm-hmm. 4 is also C.
Yeah. It's when the residual look normally distributed for number 5, right?
I think so. I was trying to look back through the book right here and see. If the linear regression is appropriate, then the residual plot will show no patterns and will consist of random scatter. If there is a pattern in the residuals, it suggests that linear regression is not appropriate. So, let's see.
Was it D?
No, you won't see a pattern.
Yeah, it says a megaphone shape occurs when points tend to be close together on one side of the graph and farther apart on the other. If there is a megaphone shape apparent in the residuals, it suggests that the variance of the error terms is not constant and that there's a difference in the spread of residuals. So, yeah, it would be it supports using linear regression if the residuals look normally distributed, I think.
Okay.
Or, hold on, would it be you see a pattern in the residuals? What did I just read?
No, because if you see...
Oh, no. Yeah, if linear regression is appropriate, then the residual plot will show no patterns and will consist of random scatter, so there would be no
patterns.
No patterns. So what does that mean for this?
Would it be normally distributed?
Yeah, that's what Lauren was thinking. I think that's got to be it.
So that doesn't mean there's a pattern, right? If it's normally
actually, yeah, you're right. And actually, if you go down to 3.4, it says once the residuals have been calculated, we can assess if they are normally distributed.
Okay.
Right. So if there are outliers in the residual plot, that suggests that error terms are not normally distributed. Yeah, I don't know. I'm going to go with A on 5.
Yeah, same here. So this is kind of off topic, but did you guys think any of the questions on the last homework were wrong?
There
I
was
think one of
one.
them.
Yeah, I think one of them was wrong.
I got all of them right, so I don't know.
Oh.
There was one on the thing that I got right, but it wasn't what I calculated. Like I calculated a number and it was like .013, and the closest number I found was .017, so I just selected that and it happened to be right.
Oh, that was a normal probability applet one, huh?
Yeah.
Yeah, that's the one I got wrong. So which one is going to be the... Or is it... Oh, it tells you.
Does it say? Oh, use confidence as the explanatory. Yeah, okay, and that's where we messed up on last time.
Yeah.
Poor Mike.
So confidence is the explanatory?
Yes.
Oh, where's this one again? Is this in the quantitative inference procedures?
Yes.
I opened the wrong one, so I'm.
Oh, yeah. It's a linear regression one, right?
Yeah, that's correct.
Yeah, that's why. Couldn't find it. And so x is always smaller than y, or is it the other way around? Or is that even... Just remember how we had them in the wrong...
Oh, so one is what changes and one is what's like constant or whatever. What you like the response variable is the one that you expect to change. So like
That'll be X, right?
yeah.
For the score? Or
Yeah,
for-
so basically what we want to see is we want to know that if they have a higher confidence, then we expect the score to be variable. And so we put the confidence rating in the explanatory. So the confidence explains the score. So that's why they have it there.
Oh man.
So is this one B?
Let me see.
Is yours linear?
Yeah, mine's like kind of hot dog shaped, I think.
Yeah.
Yeah. But I don't get the like residual thing because I'm not seeing -40 on here at all.
So the residuals are the the difference between y and the value predicted.
What do we use for X?
Oh, that's a good question. I don't know. Because that changes everything. At least the confidence intervals and stuff.
And the predicted.
I'm a little confused, or I'm lost, I guess. What am I putting where?
So you're putting the confidence rating in column A for the explanatory variable in the
both sexes?
Yes,
Oh,
just
okay.
copy the whole thing down.
That's what I was.
Yeah, no worries.
So what are we looking for on this one?
I don't know. So I'm looking at the answer key for the homework, and so one of the things that so 5 assumptions to check in order to do inference for simple linear regression. We check them. So there should be a linear relationship between x and y. So we make a scatter plot, and then we make a residual plot. So we hope to see a hot dog or cucumber shape, and there should be no pattern in the residuals.
How do you plot what?
And
Oh, you plot the residuals are over and the right, right?
I don't see them anywhere. Cause
Yeah,
like
it's right next to it. You see that?
What?
It says explanatory variable x, responsible variable y. It's in row E.
Oh, so I see. So they're saying it's between -23 and
Or it says negative
Min
40.
and max.
Yeah, so that would be A then.
Well, is there a negative 40 in there? There's a negative 38.
38.19. And then the lowest is. Oh,
There's nothing above 25.
I found a negative 38. Oh, you mean positive?
Positive, yeah.
oh, so it should be between -40 and 25.
Right.
Yeah.
Yeah.
We know that the residuals are not all
38.
negative.
And then positive 23.
So will this be A?
Yeah.
Hmm.
And so then are they fairly normal?
Yeah.
Do we see them in a QQ plot?
Well, that's the plot, right?
Yeah, it's down at the bottom of under the.
But is that for the data or for the residuals?
That's a good question.
Do you just put.
Let me go to the book real quick and check. So it's saying, to do a residual plot in Excel, once you've already entered the explanatory and response variables into the correct columns, you are given a column of residuals in column E. Highlight both column D and column E. Click on the Insert tab, and then select Scatter. So highlight column E and D.
Insert a scatter plot. The heck? Mine just gave me 1 point.
Really?
Yeah.
Did you highlight
D and E.
E
Yeah.
and E? Yeah.
I think I went down too far.
So insert. Where do we find the scatter?
One.
I think it put it down a little ways.
Oh, I see it. I see it.
Oh, so this is clearly not normal then, huh?
Yeah, mine's kind of all over the place.
But isn't that what makes these ones normal? Or is that?
That's how we know if we use a linear regression. All right.
So what are the assumptions again?
I would say they're clearly not normal. Hold on. Okay, yeah, so it's definitely clearly not normal. All right, so 8. All right, so there is a linear relationship because, like, the data is kind of scatter plot or hot dog shaped in the scatter plot, and the residuals are all over the place, which means there's a linear relationship.
Mm-hmm.
Variance of the error term is constant.
Points in the QQ plot are close to the line. No.
If there's a megaphone shape, it suggests that the error terms are not constant, and that there is a difference in the spread. But we don't see a megaphone, we see a hot dog, so there is no difference in the spread. So I think we check B. I think that might be it, but I don't know. Okay, so here's the requirements. The linear relationship, the scatter plot should be hot dog shape, which we've got. The residual plot should have no pattern in the residual, which we don't. A normal error term means that the QQ plot, the points of the QQ plot are close to the line. They are not.
So wait, if the residuals are normally distributed, then that means the data is not normally distributed?
I don't know.
Or if the residuals are like all messed up, would that make it normally distributed because that's what we want?
Yeah, that's what I think it is. So our error term is not normal. Do we select that?
Wait, so for question 7 then, are we still confident it's A?
Yeah.
Yes. Yeah, because they said that the residuals would be in a line on the QQ plot if they were normal. Yeah, so like in 3.4, it says the QQ plot of the residuals for the crocodile data show a straight line. We do not have evidence of non-normality. We conclude that the residuals are normally distributed. So with them being all over the place, then they're clearly not normal.
Oh, okay.
Right, so observations are independent, cannot be checked directly, and we hope to know the value of one of the y's. Tells you nothing about other points. But I don't know how that applies to 8. I think it's just A and B for 8, but I don't know.
I'm not sure either. Next one.
Yeah.
Well, I feel like it is dependent because they're getting a rating mean. They each get a rating mean for different scores, right?
Yeah, I think so.
So I think the mean is dependent on the score, obviously.
So how do we know that the observations aren't independent?
So let's see. The requirement for observations to be independent, it says how to check. It cannot be checked directly. What you hope to see, knowing the value of one of the y's tells you nothing about any other points.
See, like, isn't that kind of what we're seeing here?
Well,
Or am I wrong?
because it's saying I think it's because if you look at the data though, it's saying that like the score and then like the mean of that score. I don't know. I could be wrong though. 'Cause you have to have a score to have a mean of the score, right? But I don't know if I'm interpreting that right.
How do we figure out what the x is supposed to be? Because they're asking us for the confidence interval. Oh wait, but never mind. The confidence interval of the slope or of the y-intercept, that doesn't change anything. Okay, never mind.
So B1 estimate of the slope is
12.695.
yeah.
Wait, where's 12.69? Oh,
It's
Under
oh, never mind.
yeah.
and B.
Yep. B for 10.
10.6, 14.7. Ten was B, right?
Mm-hmm. So the p-value is like to the negative 23 or something. So it's going to be 0.000.
Right.
So we
Where do you see negative 23?
so if you look at they want the p-value of the slope. It's 3.31 times 10 to the negative 24,
Oh,
which means we put 24 zeros in front of the 3.
Oh, okay.
So it's 0.000, which is a lot less than 0.05. So
C.
we reject the null hypothesis because the p-value is less than. Yeah.
Yeah. If you
So-
reject it.
The slope is 0. What are we trying to?
The alternative hypothesis is not equal. So there is sufficient evidence to conclude that the slope of the regression line is not 0. So D.
Okay.
So for 13, head length is. Wait, the dependent variable. Trying to remember.
Body length, right?
Yeah, because
Because they're
The
measuring
dependent-
head length.
yeah, the dependent and the response are the same thing. So it's the body length. Body is dependent on the head length.
Yeah.
So how does that work again for which? Put it in. It's
So the explanatory variable would be head length.
I mean, like, how do you?
How do you know?
Yeah, that's what
So
I'm having a hard time
what do you measure
understanding.
that you think will change your outcome? So like when they're looking at the head size of the crocodiles, they're trying to determine that if the head size is a certain size, that the body length will be a certain length. And so they're using the head length to determine the body length.
So it's cause and effect, and
Mhm.
what you would.
Yeah.
Got it.
Confident interval.
Alright, so the head length is X.
Yeah.
And the
So the body length is the dependent variable.
yeah.
Yes.
Yeah.
Mhm. And so I think 14 is C.
C. Yep.
That's what I got.
Uh,
It doesn't give us a confidence interval, does it?
It does. So it's the confidence interval of the slope.
Oh. Oh, sorry, I mean level of significance. I guess that doesn't matter.
Yeah, so we assume 0.05, I think. But the p-value is super low.
well, it's just asking what we can say about it. We're not trying to, like, it's just looking for one of those true statement things. What's
Mhm.
which I think is A, right?
I'm not sure.
Yeah, I think it's got to be A.
Okay.
I
Brock,
guess
still here?
I can submit.
Oh, dude.
Yeah, my webcam is like breaking like a ton.
Yikes.
We got a B plus. So we got oh yeah, so we had it was backwards.
Again? For
Number
which-
no, number 7 is the residuals is fairly normal, so
Oh, because they...
7 is B, and then 8 you select C as well.
Okay.
So Lauren had it right on that one. All right.
Was that it? That was
Yeah, those two.
okay.
All right. Well, I'll see you guys later then.
Yeah, on Thursday.
Yes.
Just as a heads up, I think that Lauren and Mike, I think your parts are both due this Saturday.
Oh my.
Okay.
Yeah, you might want to check that. I think I read that in like his notes for the week or something like
Okay.
that. So you might want to just check that out. And then
All right.
if we need to, we can work on that on Thursday or something. Take a look at it.
Sounds
Yeah, we
good.
can talk about
All right. See you guys.
All right, have
it.
a
All
good
right,
night.
guys. See ya.
Good night, guys.
See ya.